All right, so now we're going to play with command injection. And the point is, you should have already done some of these Linux projects, so hopefully you're somewhat good at using Linux command line commands, because that's what you're going to have to use. So here is a command injection project, and the first one is the simplest one. If you have a router, and you configure your router has a web page you use to manage it, there's typically a feature to test your internet connection by sending some pings somewhere. So here's an example. You give it an IP address, like for example, the loopback address is the one that works on my server. And so if you give it here the IP address and send pings, it will ping, and you see some replies. Now it's pretty obvious that this is the command line ping command. And you can see the code I wrote here. It takes the data from the user, and it takes ping minus C2 and just adds the data from the user and then executes it as a system command. This is how you end up with command injection vulnerabilities. You don't figure out how to do what you're doing within one language. Instead, you use one language to make a line of code which you pass on to another language. I didn't figure out how to send a ping in PHP. I don't even know if it's possible. Instead, I just made a ping command and passed it on to the system. The reason why this is dangerous is part of that command is under the control of the user. So what if the user puts a second command here? This is a fun fact about Linux, and it's true of Windows too. On the command line, you can put two commands on the same line, and a semicolon means finish the first command and do the second command. So if I put an ls there, it will send the pings, and then it will list all the files in this directory on my server. And I can execute a lot of commands here. Now I could find out what my limitations are by say, who am I? That's a command that will identify the user. Let's see if I'm the administrator. If I am, then I have a lot of power. But in fact, I'm just www.data, which is the account the Apache server runs under. So I'm not the administrator, but still I can do a lot on the server. And you can see there's a file named flag1.txt. So if I know my Linux command line commands, I'll be able to print the contents of that file. And there's a series of flags to find here that get harder and harder to find. And here's some commands you can look up. These versions of these commands will make it possible to find the contents of these flags. So that's the first simple case of command injection. And I got a couple more here. This one shook the whole web in 2014. People at that time believed that Windows was more secure than Linux, and this was one of the big wake-up calls that it's not that simple. So we can upload an image here. Let me find an image, like say this textbook image will do. If I open image in new tab, and then I save it, let's put it on my desktop, and it's called a hacking API. That'll do. Okay, so there's an image. Now this is the code that you might find on any Linux server to handle images like profile pictures or anything else. It's called ImageMagick. It's the standard library, and I just copied some standard code from like message boards, so I can select a file like desktop and their textbook name, okay, and I can upload the image. And what it's going to do is it's going to show you what it's doing more than most pages do. It's creating a thumbnail. See, it's created a thumbnail version at a certain size, and when you click the thumbnail, you see the original image at its original size. That's what this does, and this is a common thing. But the way it did it was by executing this command. Convert is an ImageMagick command, so it took the file I sent and put it in an upload folder, and then it used this command to convert it to a 300 by 300 thumbnail. So that's fine. The only problem is, it turns out that there's an code injection vulnerability in the ImageMagick library. And to see it, you make a text file containing this data. So I'm going to go to my text editor, and I'm going to put that data in a plain text file, and I'm going to save it as if it was an image. So I save it on my desktop as exploit.jpg. It's not a JPG file, but I use that file name. All it contains is this text. And now when I upload that file, choose file, I said choose file, there are exploit.jpg, and then upload. What it does is it runs the convert command, and then it prints hello and the date. Now let's look at what was in that file. What happened here is the people that wrote ImageMagick decided it's not enough to just process images. They want to make it possible to modify images, so they let you put extra text in the image file that would add colors to it. So it's going to determine a region of this size. It's going to fill it with a color. And then they decided it's not enough to just fill it with a static color. They wanted to make it possible to load the color name from a website so you can change it. And so that's what this fill URL does. It's going to load from a website, and they implemented that with the curl command, which is the command line web browser on Linux. And so they execute a curl command, and then they put in data that came from this file. So if you have the right punctuation marks like this, the right quotes and all this jazz, you can now put a Linux command, echo hello and date here. So it's code injection just like before, but you have to put the code in an image file and send it up. And when you do, it executes these two commands. So for example, I can change that date to who am I to find out what privileges I'm going to have with this attack, save the file again, upload the file again, and process the uploaded image, and now I get hello, and I get the name of who I am. I'm again www.data. I'm getting the privileges of the Apache user. So I can now execute any command on the server I want to by putting it in this image, in this text file, and sending it up. And so again, you can find some flags on the server with that. There's a series of flags to find, a couple of them here. And there's another one, even more fun, Drupal. Drupal is a competitor with WordPress. WordPress is what I was trying to remember earlier. It's a PHP-based software used for something like 7% of the entire internet. It makes it easy to make beautiful web pages, but it has a lot of dangerous extensions. Drupal is a competitor, and it has had a whole series of spectacular security flaws. They called it Drupalgeddon and Drupalgeddon 2 and Drupalgeddon 3. And here's one of them. I've made a vulnerable Drupal server here, which does get hacked a lot. Let's see if it's working. I put a login to protect it that is just student 1 and student 1 is all it is. It's not very secure, but it stops automated attacks from trashing my server all the time. Okay, here's my server, and it doesn't have any content, but you can exploit it, and you exploit it with this script. This is a Python script that will exploit my server. So you can run this in any Python environment you like. I'm going to use my Mac native Python environment, just open terminal. You could use Google Colab or any Python environment that has internet networking. Let me just cd, let's see, 129s, do I have such a thing? Space, okay, let's make a directory, 129s, and go in there. Okay, now I can nano drew.py, and I can put in that script. Now, the one thing you have to do in this script is you have to displace your name, your name, your name. You have to field it in 3 places. I'm going to make it your name 11. That might do it. You have to change this every time you run it. So what is going to happen is the registration form had a code injection vulnerability. So if you send it this data, trying to register a new user, part of it, I think the email feature had this, you see, after all the punctuation, here's some commands. This is going to echo a smiley face character and put it in a file called yourname11.txt. This is where you put the injected code. You have to put it in, surrounded by all this surrounding stuff in order for it to work. So you put it there, and then you run this script. All right. And it will tell you, it appears to have worked. If it worked, it will execute that code and put the output in this file, yourname11.txt. So let's see if that file was created. And it was created, and it contains a smiley face. So the server is vulnerable, and I can do anything I want. So for example, if I want to list the files, I edit this script. Oops, edit the script, there we are. And now first thing I got to do is change that name. So I'll make it yourname12, because you can only write each file once, and you can't modify it. So you have to create a new file to get the output of each command. And now the commands are up here. Instead of echoing a smiley face into the file, I'm going to do, say, an ls into the file. That should give me a list of files on the server and put it in this file called yourname.txt. Let's see if that works. Okay, look at yourname12.txt. And there we go. That gave me a list of files. And these files are mostly being created by students. The server gets really clogged up with all these junky files. But anyway, there are some flags there, and you can find them. Although in this case, it's a little harder than you might think because students are creating, by accident, files named flag that aren't the right flag. So you have to be a little more careful. And there's information here about the flags. But the clue about the real flags is they were created on this date in 2019. The ones students created have later creation dates. So that's a way you can tell the real flag files from the fake flag files. So that's what I wanted to show you. These are examples of command injection that you can practice with. And you get to see how to do it. You have to know some Linux command line commands, and you have to get used to encasing it in these structures that fool the server into executing them. Let me check for comments in the Twitch. Nothing, okay, nothing new, so that's it for that. I'm going to stop this recording.